So let's finish off this question. We said we have to do now x to the power ln x derivative. And what's so different about this question is that we don't have x to just a power, x to the power of n, because then we would use the power rule. But we have x to a power of x itself, of the variable of interest itself. So it's a bit different. Now, because it's a bit different, we also solve it slightly differently. And how we do it is that we note that x to the power ln x is a function, and that function is y. Well, indeed, x to the power ln x would give a result, and if we draw it on a graph, we would get a value on the y-axis. So it's, legit to say that x equals to ln x. Now, why do we do this? Well, because we have this logarithmic property here, ln to the ln of x, and we would like to use our logarithmic properties. So let's try and take the ln of both sides. If we take ln of both sides, what do we get? Well, we would have that ln of y is equal to, remember, in a logarithmic property, we know that we can take the power down. So that would be x times ln of a. And in our case, our power is ln x itself. So if that comes down, we would have ln of x times ln of x. Well, that's already looking better because we have something, something more neat. We have ln of x to the power of 2, which means that ln of y is equal to ln of x to the power of 2. But our whole purpose is to take the derivative of x to the power ln x. Our whole purpose is to find out what is the derivative of this side. And if we want to find out the derivative of this side, well, that's because it's an equation, we can also solve the derivative of what we have at the moment. Ln of y equals to ln of x squared. Once we take the derivative of both sides in this case, the final answer will give us what is x to the power ln x derivative. Because again, it's the same thing that we started, but we're just playing a bit with logarithms, adding to one side, adding to the other side. We're still having the equation, so we're still having the power to say that we are differentiating what we began. So ln of x to the power of 2, let's take the derivative of each side. So ln of y derivative, ln of x squared derivative. Ln of y derivative, well, that's 1 over y, but then remember, y over here is a function of x. That's what we said. It means it's an expression. It means chain rule, so we're differentiating this y. Now what is ln of x squared derivative? Well, that's the power rule first, but then we also use the chain rule because we have an expression inside, so we're differentiating ln of x. Okay, let's keep going. We have 1 over y times y derivative. So we have 1 over y times y derivative equals to 2 times ln of x times ln of x derivative is just 1 over x. Now what was y derivative? Let's go back and see. Y derivative is our initial function, x to the power ln x. That was our y, and we differentiated, and that's exactly what we're looking for. So what we want now is to keep y derivative on one side, because that's going to be our final answer. How do we do it? Well, let's do a cross product, because we have y derivative divided by y. Well, in that case, if we multiply in cross, the y multiplies with 2 times ln x times 1 over x. So we'd have 2 times ln x times 1 over x times y. And let's just substitute to finish it off. Y derivative, well, we said that y equals to x to the power of ln x, and we differentiated. That was our whole goal. And it's equal to 2 times ln x times 1 over x multiplied with y, multiplied with what we said in the beginning, x to the power of ln x. And there we have it. That was our derivative. Now this whole thing, we did it for the sake of substituting into our limit. So let me zoom out so we can see better. We're substituting this thing into our limit, which means that we will have now, so this goes here, which means that now we can write this limit as x approaches infinity, limit as x approaches infinity of 2 times ln x times 1 over x divided by 2 times ln x times 1 over x multiplied with x to the power ln x. Remember, this is just this expression that we substituted. We notice something, that we have the same terms. 2 ln x and 1 over x, here and here. We can cancel them out, so we are left with the limit as x approaches infinity, and then we have 1 divided by x to the power ln x. Now what is x to the power ln x as x approaches infinity? Well, we would have that we divide 1 by infinity to the ln of infinity. Infinity is a very large number. To any power will still be even larger, so 1 over infinity. If we divide 1 by a very big number, we get very close to 0, so our result will approach 0. And that's it. That's the final answer. We are done.